Okay, recording for whoever is watching this. Chapter 12 review for geometry. We're doing the last 4 problems on this page. I think I assigned as homework. And then this back page. Okay, so check your answer. I can't yell very loud today, and I can't hear myself yell because, like, this ear is deaf. So you gotta, like, take it easy on me. This one says pointer landing on red. Red is, 40 degrees out of a total of how many? 360. So to reduce that, I can cross a 0 off, and 4 over 36 is 1/9. So there is that, yeah?
The spinner landed on. Can we just leave it?
What if the oh, yeah, good question. What if the spinner lands on purple? What's the chances of the spinner landing on purple? How do I find that? Yeah, I would add all these, subtract from 360, and figure out what purple is, right? Does that make sense? Okay. This one is pointer landing on blue. 30 out of 360, which, if I cross the 0 out, is 1/12, right? So 1/12 is the second one, yeah? Happy with that? 1/9 and 1/12 for those two? Okay. Number 19, George has. These questions are notorious for making lists, and whenever I see this start, like on maps testing or on the ACT, I start making the list. So 2 red, I list them off to the side so I don't have to reread. 4 black, 2 white, which is a total of 8 socks. Okay, we want to know what is the probability of picking a red sock and a white sock. I'm circling the word and because and means multiply. I'm multiplying because there's 2 socks that I'm choosing. Hold on just a second. Okay, go fast. 2 socks. I want a red first and then a white, and is replaced. Is replaced. Okay, what's the chance that the first one is red? 2/8 or 1/4. If I replace it, now I still have 8 socks, but how many are white? 2. Okay, and if I reduce, this is 1/4 times 1/4, and 1 times 1 is 1, and 4 times 4 is 16, so there's that. Yeah? 1/16. Okay? Phyllis drops a penny in a pond, and then she drops a nickel into a pond. How many things is she doing? 2, which means we are? Multiplying. Okay. What is the probability that both coins land tail showing? So I want a tail and then another tail. 1/2 is the chances of it landing tails. 1/2 is the chances of it landing tails, which is 1/4. Which is a quarter. Or 25% or 0.25. However you want to do that. Okay. All right. Next page. 21. Here we go. Mr. Haynes places the names of each of his 4 students, circle that, on slips of paper. From these, he intends to randomly select 2 students to represent his class at the robotics convention. He draws the name of the first student, sets it aside. What does sets it aside mean? No replace. Sets it aside means no replace. Then he draws the name of the second student. What is the probability he draws? Juanita? I don't know. I'm just going to put J. I'm going to put Juan and then Joe. Okay. Am I adding or multiplying? Multiplying because you're selecting 2 people, right? What's the chances that he selects 1? 1 out of 4 because he is only 1 out of 4 person. All right. Now I'm not replacing. So how many slips of paper are left? 3. And how many say Joe? 1. So the chances of that combination happening exactly is 1/12. Okay. Next. We have to find the probability, but also exclusive or inclusive, right? Exclusive or inclusive. Do you remember the difference between the 2? Exclusive. Junior, senior is exclusive because you can't be both. Boy and junior. Inclusive, because you can be both, right? Okay. All right, shelter, selecting a cat or a dog. First of all, inclusive or exclusive? Can you be a dog and a cat at the same time? No, exclusive. I realize it's 2024, almost 2025, but no. I don't care what you identify as. All right. 15 cats, 25 dogs, 9 rabbits, 3 horses. That sounds like a list. How many all total? 24? That is not right. 52? That is correct. 52. Okay. Selecting a cat or a dog. Maybe I should circle the word or. Or means add. How many are cats or dogs? Let's do cats. Is 15 out of 52. Dogs is 25 out of 52. Or means add. So 15 and 25 makes 37 out of 52. Does that reduce? I think 37 is prime. What? Is it really?
It's not 37.
It's not 37 because I can't math. 40 over 52. Which is, you're right, 10 over 13.
Oh, do you think one of them was a 2?
I don't know. Yes, I thought one of it is a 2. I don't know. 10/13ths. But or means add. Okay? All right, here we go. 23, rolling a 6 or, which or means add, an even number. 6 or even. Inclusive or exclusive? Can you be 6 and even at the same time? Inclusive. Inclusive. All right, so rolling a 6. How many sides on a dice have the number 6? 1. How many sides on a dice are even? 3. How many are doubled? 1. So if you're going to do this the math way, 1 over 6 plus 3 over 6 minus the 1 in the middle, right? Which is 3 over 6, which is 1/2. If you want to, the sides on a dice are 1, 2, 3, 4, 5, 6, right? This number is not 6 or even. This number is 6 or even. This one is not 6 or even. This one is 6 or even. This one's not 6 or even. This one is 6 or even. It's double. It's both, right? How many of that is there? 3 out of 6 or 1/2. If you want to do it that way, that is totally fine. The red circle is over here. I was explaining what inclusive and exclusive were. Exclusive is junior, senior. Inclusive is like boy and junior. Could be both, right? Okay, next. All right, grab bag. From a grab bag, a birthday child gets to randomly pick one of 20 envelopes. 1 out of 20. 10 of which contain toy store discount coupons. 8 of which contain gift cards and 2 of which contain cash. So I have 10 coupons. I have 8, what are we talking about? Gift cards. And 2 cash. Okay, which makes total of 20. What is the probability that the birthday child selects a gift card or cash? Or means add. Now, can you get one gift bag that has gift card and cash at the same time? One bag that contains a gift card and cash at the same time. Each bag only contains one.
So it's exclusive.
So they are exclusive. If you choose 2 bags, you could get both of them, but you're only choosing 1 bag. So this is exclusive. Do we see why it's exclusive?
No.
There's only one gift per bag, right? There's only one gift per bag. So if I pick up 1 bag, is there a chance I could get a gift card and cash in the same bag? No. So they are exclusive, okay? All right, what's the chances that I get a gift card? Gift card is 8 out of 20 plus, because we're adding, cash is 2 out of 20. So 10 out of 20 or 1/2. I have a 50-50 chance of getting a gift card or cash in my thing, right? Because the other 50% are coupons, right? Okay? Good? All right. 25. A spinner with 8 evenly sized sections numbered 1 through 8 is spun. Here we go. Whoop, 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 whoop. 1, 2, 3, 4, 5, 6, 7, 8. 8 evenly spun sections. All right. Find the probability the number spun is 6, given that it's an even number. This is one of those conditional probabilities. All right. Probability of getting a 6 given even, right? That's what that bar means. All right. How many options did I have originally?
First of all, it's inclusive.
What? Oh, we don't have to do inclusive and exclusive. That's only up through 24. Yep. You're right, though. It would be, but this is conditional probably, a little bit different. Okay? All right, so originally I had how many outcomes? Originally I had how many outcomes? 8. But now that I know, given that it's an even number, now I'm down to just 4, because given even is only 4 numbers, right? How many of them have 6s on them? 1 out of 4, right? So instead of being 1 out of 8, I go from 1 out of 8 to 1 out of 4 because I know it's an even number now, right? Okay? Questions about that? That was a conditional. All right, a dice is rolled. 1 dice, right? If the number rolled is less than 5, what is the probability that the number is 2? Okay, are you guys all listening to this one? This one is worded weird. 26. Listen. If the number rolled is less than 5, do you know another word for if? Given. Given the number is less than 5, what is the probability that the number is 2? Okay? What are numbers less than 5? 1, 2, 3, 4, right? Numbers less than 5. So instead of my bottom number being 6, now my bottom number is only 4. What is the probability that the number is 2 exactly? 1. 1/4. Okay, beautiful. 27, 28, 29. Make a two-way frequency table of the data. All right. 100 students were surveyed about whether they like fruit. 100, where does that go? Total. 100 students, whether they like fruit. Their survey showed that 25 boys and 35 girls like fruit. Where does that go? Fruit column. 25 boys and 35 girls, which makes a total of 60 students that like fruit. How many students don't like fruit? 40? 40? 25 boys and 15 girls don't like fruit. How many boys were there total? 50. How many girls were there total? 50. Okay, I'm going to change these to blue. All right, the pink ones are called what kind of frequencies? Those are joint frequencies. The pink ones are joint frequencies because they join together to make the total. Joint frequencies. Okay, what about the blue ones? Those are called marginal. Do you remember how to remember that? They're on the margins, right? Margins are outside. So joint frequencies, marginal frequencies. Okay. Oh, hey, they asked us that question. Make a two-way frequency table of the data. How many girls were surveyed? 50. Is this a marginal or joint frequency? Marginal. Yeah? Okay, because it's on the outside. Okay, find the probability that a surveyed person, find the probability that they were male, given that they like fruit. So that's what we're finding. Male given fruit. My bottom number was originally 100. But now I went from 100 down to the fruit people, which are only 60. How many of the 60 are males? 25. If I divide by 5, I get 5/12. Questions about that? Can we do what? 21? All right, go get a whiteboard. I'm going to stop the recording.